Welcome back to the channel. Today, inside this massive factory, we're exploring how fresh flowers are transformed into pure essential oil.
An entire industrial ecosystem exists to capture the invisible scent locked inside fresh flowers.
Prohibitions. Every drop of essential oil begins in careful cultivated fields. Timing the harvest is critical to preserve.
The fragrance molecules are most potent at this stage. But before extraction can begin, the flowers must move quickly to the factory.
Speed and temperature control protect the delicate chemistry inside each petal. Even small delays can reduce oil yield.
Different flowers require different extraction techniques. Sorting ensures each batch enters the correct processing line. Precise measurement determines how much steam, pressure, and time each batch will need. Accuracy begins long before distillation.
Only fresh, undamaged blossoms move forward. Quality control starts at the very first touch point.
Controlled cooling slows natural degradation. This preserves volatile aromatic compounds before extraction.
Temporary storage keeps production continuous. But flowers cannot wait long. Fragrance fades with time.
Moisture levels influence the efficiency of steam distillation. Monitoring begins before heat is ever applied.
Some varieties require gentle cleaning to remove dust. The process must remain delicate to avoid damaging oil glands. Excess surface moisture is removed before extraction. This ensures purity in the final oil.
Uniform packing allows steam to pass evenly through the plant material. Even distribution affects oil yield. While flowers are prepared, the distillation system powers up. Temperature stability is essential before extraction begins.
These stills form the heart of the operation. But they remain silent until the flowers are ready.
Each flower variety follows its own path. The factory is designed to handle multiple botanical profiles simultaneously.
A sealed environment ensures pressure remains controlled. Any leak could compromise the entire batch.
Prepared blossoms are now positioned for transformation. The process is about to shift from preparation to extraction.
Every parameter is programmed in advance. Distillation depends on controlled heat and precise timing.
Inside these chambers, fragile petals will soon release their concentrated effort.
The system prepares to introduce steam. This controlled heat will unlock the oils hidden within plant cells.
Water transforms into pressurized steam. It is this simple element that drives the entire extraction process.
The factory shifts from quiet preparation to active production. The true transformation is about to begin.
As steam touches the petals, microscopic oil glands begin to rupture. Fragrance is slowly released into vapor form.
From field to chamber, every step has led here. This is only the beginning of how flowers become essential oil.
But what happens inside these sealed vessels determine everything. In the next stage, heat and
steam now enters the packed chambers at a controlled rate. The temperature must rise gradually to avoid damaging delicate aromatic compounds.
As heat builds, essential oils vaporize alongside water. The mixture rises toward the condensation system above.
The oil-infused steam exits the chamber immediately. Rapid transfer prevents loss of volatile fragrance molecules.
Inside the condenser, cold water lowers the vapor temperature. This forces the aromatic steam to return to liquid form.
What emerges is a mixture of water and essential oil. Separation has not yet occurred.
Cooling must remain constant throughout the cycle. Even minor temperature fluctuations can affect purity.
The condensed liquid enters a separation vessel. Here, density differences begin to do their work.
Essential oils are lighter than water. Over time, they naturally rise and separate into a distinct layer.
This fragile layer contains the concentrated essence of thousands of flowers. Precision handling is critical from this point forward. The upper oil layer is drawn off gradually. Flow speed must remain slow to avoid mixing with water below. The remaining aromatic water, known as hydrosol, is preserved for other applications. Nothing from the process is wasted. Before storage, the oil passes through microfilters. This removes plant residue and microscopic impurities.
Filtration ensures clarity and stability. Even trace solids can impact long-term shelf life. Freshly extracted oil moves into temporary holding tanks. Each batch remains isolated for traceability.
Every extraction cycle is recorded in detail. Data ensures consistency between batches harvested on different days.
Once steam exposure ends, the spent botanical material is removed. The majority of its oil content has already been captured. The extracted flowers are separated for composting or biomass reuse. Sustainability remains integrated into the process. Residual heat is often recovered for energy efficiency. Even waste material contributes to overall production. Natural variation exists between harvests. Color and viscosity may shift slightly depending on flower maturity.
Samples are drawn for preliminary testing. Chemical composition must meet expected standards before refinement continues.
Clarity indicates proper separation and filtration. Any cloudiness suggests residual moisture. Extraction operates continuously in rotating cycles. This ensures a steady output throughout the harvest season. Temperature and pressure remain under constant adjustment. Stability protects the integrity of delicate aroma compounds.
At this stage, raw essential oil has been captured. But refinement and precise balancing still lie ahead.
The initial extraction is complete, yet the journey is far from finished. Next comes the
of the plonges. The extracted oil now enters the core manufacturing stage. Here, refinement separates the most.
Temperature gradients are carefully controlled along the column. Each level allows specific aromatic molecules to condense at precise points.
Heat gently reintroduces vaporization. This controlled phase isolates the purest fragrance components.
The reboiler supplies consistent thermal energy. Stability at this stage determines overall product quality.
As vapor rises, partial condensation occurs. This reflux cycle enhances separation efficiency. Multiple columns operate in parallel. Automation maintains uniformity across high production volumes.
Centrifugal systems further remove microscopic moisture. High-speed rotation accelerates separation.
Residual water is eliminated at this stage. Dry oil ensures longer stability and purity. Vacuum distillation reduces boiling temperature. This protects fragile aromatic compounds from thermal degradation.
Lower pressure allows refinement at milder heat. The result is a cleaner, more delicate fragrance profile.
The vacuum system maintains controlled internal conditions. Precision here prevents contamination.
Refined fractions are now recombined in exact proportions. Blending restores balance to the aroma profile. Each fraction contributes specific notes. The final scent depends on controlled recombination.
Flow rates are calibrated to the milliliter. Small adjustments shape the final character of the oil.
Homogenization ensures molecular uniformity. This prevents separation during storage. The fully refined oil moves towards stabilization. Its composition is now consistent and concentrated. Air trapped during blending gradually escapes. This step ensures visual purity.
Gas chromatography confirms molecular composition. Each aromatic compound appears as a measurable peak.
Results are compared against strict formulation standards. Consistency defines industrial reliability.
The core transformation is complete. Raw extract has become refined essential oil.
Now purified and balanced, the oil is ready for final precision adjustments. The next stage focuses on refinement at an even finer scale.
From large-scale transformation, the process now moves toward meticulous fine-tuning. Precision will define the final character of the oil.
After large-scale refinement, the oil enters a precision environment. Here, even the smallest variations are corrected.
Polishing tanks maintain exact thermal stability. Temperature shifts of even 1 degree can alter aroma balance. Ultra-fine filters remove particles invisible to the eye. This stage improves both clarity and longevity. Filtration at the micron level ensures purity. Only refined liquid continues forward. Optical sensors analyze light absorption. Color consistency reflects chemical stability. Data guides minor formulation corrections. Adjustments are measured in fractions of a percent.
If necessary, trace components are rebalanced. This maintains the intended fragrance profile.
Rebalanced fractions integrate gradually. Slow mixing prevents turbulence and oxidation. Inert gas protects the oil from oxidation. Exposure to air can degrade sensitive compounds. Controlled resting allows the oil to stabilize naturally. Aromatic notes harmonize over time.
Clarity improves as trapped air escapes. The liquid becomes optically pure.
Mass consistency confirms proper blending ratios. Exact weight reflects correct formulation.
Refractive index reveals concentration accuracy. Deviations indicate molecular imbalance.
Viscosity affects handling and packaging performance. Controlled thickness ensures predictable flow.
Even minimal moisture is measured again. Absolute dryness prevents microbial growth.
Acidity levels influence long-term stability. Controlled neutral balance is essential.
With corrections complete, the oil advances. Flow remains steady and contamination-free.
Before transfer, seals are verified. A secure system protects purity. The refined essential oil now rests in controlled isolation. Its composition is stable and verified. Buffer tanks prepare the oil for controlled release. Flow timing becomes critical in the next stage.
Every variable meets specification. Approval clears the batch for final inspection procedures. Large-scale transformation has given way to meticulous calibration. Now the focus shifts to verification and standards.
With refinement complete, the oil advances toward inspection. The next phase determines readiness for market release.
Precision has shaped the final composition. What follows will confirm its consistency under strict quality control. The refined oil now enters its most scrutinized phase. Every batch must prove its consistency under controlled laboratory testing. Samples are collected under sterile conditions. Contamination at this stage would invalidate the entire batch.
The chromatogram reveals the oil's chemical fingerprint. Even minor deviations are immediately visible.
Results are matched against established standards. Consistency confirms process stability.
Visual clarity is examined under controlled illumination. Any haze suggests residual moisture or impurities.
Light absorption analysis verifies color stability. Subtle tonal shifts can indicate imbalance.
Viscosity determines handling performance. Proper thickness ensures smooth filling later in the process.
Viscosity determines handling performance. Proper thickness ensures smooth filling later in the process.
Although essential oils resist microbial growth, verification is still required. Sterility protects long-term stability.
Acidity levels are checked once more. Chemical neutrality supports product longevity.
Residual moisture must remain minimal. Dry oil ensures structural integrity.
Reference samples are preserved for traceability. Every batch can be reviewed months later if needed.
Final approval requires complete documentation. No parameter is overlooked.
Only after verification is the batch cleared. Authorization activates the finishing sequence.
With certification complete, the oil moves forward. The focus now shifts to precise filling and containment.
Transfer lines remain sealed to prevent exposure. Clean movement protects the oil's integrity. Containers are sterilized before filling. Even packaging must meet purity standards.
Precision pumps measure each fill volume accurately. Uniformity ensures consistent product distribution.
Sealing prevents oxidation and leakage. A secure closure protects the fragrance within.
Leak testing confirms structural integrity. Only airtight containers continue forward. Imperfections are analyzed immediately. Continuous feedback improves process precision.
Each approved unit represents thousands of harvested flowers. The transformation is nearly complete.
Quality control confirms the oil's purity and consistency. The final stage will prepare it for storage and global distribution.
With filling complete, the essential oil enters its final phase. The focus now shifts to protection, presentation, and readiness for distribution.
Each bottle is labeled with batch data and trace codes. Accurate identification ensures full product traceability.
Permanent coating is added for long-term tracking. This information links every bottle to its production cycle.
Seal strength is verified one final time. Proper torque prevents leakage during transport.
Tamper-evident seals protect product integrity. Any interference becomes immediately visible.
Automation ensures careful handling. Precision reduces breakage and maintains efficiency. Packaging materials are assembled on-site. Structural strength is designed to absorb transit impact. Sealing completes the protective enclosure. Secure cartons safeguard the finished product.
Finished cartons move toward bulk handling. Efficiency at this stage supports large-scale distribution.
Palletizing organizes units for transport. Uniform stacking maximizes storage efficiency. Stretch wrapping stabilizes the load. Movement during transit is minimized.
Final scanning records pallet data into the logistics system. Traceability extends beyond the factory floor.
Autonomous transport systems move finished goods to storage. Efficiency reduces manual handling risks. Storage conditions are carefully regulated. Stable climate preserves aromatic integrity.
Inventory is organized by production date. Rotation ensures freshness in global distribution. Distribution begins at the loading bay. Each shipment carries concentrated fragrance derived from vast fields of flowers.
Sealed transport protects the cargo. The journey now extends beyond the factory. From cultivated fields to industrial refinement, the transformation is complete.
Smaller packaging formats are prepared for various industries. Cosmetics, aromatherapy, and pharmaceuticals depend on this supply.
Inside each bottle lies the concentrated essence of thousands of blossoms. The journey from petal to purity is complete.
The final product reflects precision at every stage. Its stability results from controlled heat, pressure, and refinement.
Production continues in cycles. Harvest seasons may change, but the system remains constant.
An industrial process has captured something delicate and invisible. Fragrance has been preserved through engineering. From field cultivation to final shipment, every step was measured and controlled. This is how